And welcome back, students. As we get into our last topic for Programming 2 review, let's dive into recursion. So first thing we have to remember is the iterative versus recursive design. Up to this point, we've kind of focused on the iterative aspect. This is where we use iterations or repeated process of operations. For example, loops. Loops are a great example of an iterative approach because we can do things over and over again. However, there is a second form of design for applications, which is known as recursion. Now, recursion is the process in which a function will call itself either directly or call itself indirectly. Now, remember that recursive cases need to have both a base case and the recursive case. Recursive case is where it generates the stacks and stuff like that in order to call the function over again. The program will keep track of those. Now, with recursion itself, in a recursive program, the solution to the base case is generally provided within the code. And the solution of the bigger problem is therefore expressed in terms of smaller problems. So for example, the base case for n is less than or equal to 1 is defined, and larger value of numbers can be solved by converting to smaller one till the base case is reached. So here in this example, I have int fact of int n. So if n is less than or equal to 1, return 1. Otherwise, we're going to say return n times fact of n minus 1. So this is a factorial example. So in this factorial, of course, if it's less than 1, just return 1. 1 factorial, 1. 0 factorial, 1. All right. Otherwise, you're going to take that number, multiply it by the previous iteration. Remember, factorials are a great example for recursion because when you do a factorial, for example, if you do 5 factorials, 5 times 4 times 3 times 2, etc. So it is a great example of a factorial. Now, if we actually want to solve a problem using recursion, the idea is to represent a problem in terms of one or more smaller problems, and then add one or more base conditions that can stop the recursion. So for example, we compute factorial n if we know the factorial of n minus 1. So if we know the previous value, let's say I know that 3 factorial is the same as 3 times 2 times 1, which is 6. So then I know that 4 factorial has to be 4 times 3 factorial. So the base case for factorial would be n equals 0, and return 1 when n equals 0. All right, I've already mentioned this a little bit, but recall that recursion uses stacks of memory in order to keep track of the recursive calls. Every time it makes a call, it puts a stack. It makes another call, puts a stack on top, etc. Now, when the recursion is solved and the program starts pulling those recursive calls back in order to solve them, it must work through each stack in order of the most recent to the oldest. However, if the base case isn't reached or not defined, then the stack overflow problem may arise. So if n equals 100, return 1. Else, return n times factorial n minus 1. Now this one, if you look at it, it says n equals 100. Return 1. The issue with this, okay, is that this right here is going to never be true. It's never going to be true. Like 100 factorial is never going to be 1. So this base case will never be reachable. All right, now there are advantages and disadvantages of recursion. One of the biggest strengths of recursion is the ease at which code can be written. Right? It's very much more suited to the programmer's mindset. You might find it your own self maybe a little more difficult, and that's because you're maybe used to the iterative approach, which of course has advantages over recursion, because one of the biggest drawbacks of recursion is that it has a greater time and space requirement. It needs more memory. It needs more time to process because it has to pull all this up constantly and then pull it back in. Whereas the iterative design, it just kind of goes. All right, that's going to wrap it up for our review. I'm going to give you guys some access to materials in the notes, like always. But other than that, that's going to be a kind of a quick wrap up. We have a couple labs to work on, but then that's it. I'll see you next time.